My name is Chloe Dawson Taylor. I am 5'6" and 3/4 and I weigh 130 pounds. And this is physics.
Now let's take a look at kinematics and Chloe's max speed. To find Chloe's initial velocity, we're going to time how long it takes her to go from the flags to the wall and do her flip turn. Then we're going to divide her displacement of 5 meters that it takes to get from the wall to the flags by her time that we have found. If you're wondering why we decided to get Chloe's velocity initial from the flags to the wall as opposed to from the start of the race with her dive, it is because the acceleration from the dive is so great that it would have made her velocity initial average inaccurate. To find Chloe's velocity final, we timed how long it took her to go from the second set of flags to the wall. We then divided the displacement of 5 meters from the flags to the wall by her time. Since Chloe's final velocity was 1.4 meters a second and her initial velocity was 1.3 meters a second, it can be determined that her max speed was her final velocity of 1.4 meters a second. Since it is easier to keep an object in motion than to get it started moving, it makes sense that this would happen considering that the force of friction static is greater than the force of friction kinetic. To find her acceleration, we must first find total change in time. To find this, we add the change in time 1 and the change in time 2, which we already gathered in the max speed question. We then add to this change in time 3, which is the change in time from the end of delta t1 to delta t2. This value is 13.6 seconds. Therefore, our total change in time is 17.45 seconds. To find acceleration, we then subtract her final velocity by her initial velocity, which we've already found. We then divide this number by total time to get acceleration. Therefore, Chloe's acceleration is 0.006 meters a second squared. Chloe's projectile motion. After calculating our displacement and time, our unknowns are velocity vertical final and velocity horizontal. With our givens, I have calculated the velocity horizontal and velocity vertical final. Let's move on to forces with Newton's first law. Let's relate Chloe's flip turn to Newton's first law. Chloe is in motion going into the wall at a constant velocity and direction. When she is approximately 0.2 meters away from the wall, Chloe applies an unbalanced force by applying a downward force on her head and applying force to her thighs to curl them against her body. Chloe is able to change her motion and speed of direction by applying an unbalanced force to her body. Newton's second law states that force equals mass times acceleration. We can find Chloe's force net by using the acceleration already gathered in kinematics and converting her weight from pounds to kilograms. We then find her force net by multiplying her mass by the acceleration. Newton's third law states that for every action there is an equal and opposite reaction. Here we see Chloe using her arms to propel her through the water. Her arms are pushing the water backwards and behind her. For this action, the reaction force is the water then reacting and pushing her forward, which is the opposite direction from which she originally pushed the water. Let's now look at the types of forces involved. These are the forces that act on a swimmer. Because force of buoyancy and force applied are greater than force of gravity and force of drag, they have longer arrows. Back in 2009, Speedo created their laser racing bathing suit, which helped swimmers shatter world record. How did the bathing suits do it? The answer is that they were made of polyurethane, a fabric designed to imitate a shark's skin so that they don't absorb water. The suits were also shoulder to ankle in length and tight to compress your surface area. Lastly, the suit trapped air inside it before the race, adding buoyancy and reducing drag. Due to unfair advantage, the suits were banned in 2010.